Hello, everybody, and thank you for coming to our production engineering alumni panel today. My name is Amanda, and I have with me several incredible graduates from our production engineering fellowship program. So in a minute, I'm going to introduce them, and I will start asking them questions. The way this is going to go is I'll have all of my speakers come up on screen, briefly introduce themselves and share who they are, what year they went through the production engineering fellowship, and what they're doing now. And then I have a list of questions to ask our panelists, but I'm really interested in what you all want to ask our panelists. So while we're talking, please drop your questions at the bottom, in the chat. And at the end, I'll save some time for audience questions. So keep that in mind. Ask people questions or ask questions in the chat as things are going on, and I'll be sure to circle back to those when we have time at the end. So what I'm going to do now is bring on all of my panelists. I've got Jimmy, Jimena, Lovinson, and Eric, who I will be bringing on to introduce themselves. And I'm going to go ahead and start with Jimmy. So Jimmy, I'm about to add you to the stage.
Hi, can you hear me?
We can.
Okay, cool. Should I begin?
Yes, please.
Okay, so I was a fellow, I think, a year ago. I did the entire program from start to finish. It was an amazing program, and I'm very happy to speak about it today. Through the program directly, I was able to get an internship with Meta, from which I got a full-time offer, and I'm starting in July, right after I graduate college.
Amazing. Amazing. Thank you, Jimmy. Lovinson, I'm going to pull you onto stage now. Please introduce
Hello.
yourself.
Hello, my name is Lovinson. I did the fellowship a year ago as well. I was in the production engineering track, and through that fellowship, I was able to land a job elsewhere at Pinterest, and I am returning at Pinterest for next year.
Congratulations. That is amazing. Jimena, over to you, adding you to the stage.
Thank you. Hello, everyone. I was also, like everyone else mentioned, in the production engineer track a year ago. I think it was a great experience, and I think it contributed to the fact that I got my job right now at Medallia. I'm actually completing my 2-month training, and I'm going to be starting full-time as a professional services consultant today, actually.
Whoa, and on your first day starting full-time, you come to do this panel for us. That's
did.
incredible.
I have a great boss that gave me a chance to be here with you guys.
Amazing. You'll have to send me his email so I can rave about you to him. And then last but not least, we have Eric. Eric, welcome to the stage.
Hi, thank you, Amanda. Hey, everyone. So I'm Eric, and I, like everyone, I also did the fellowship last summer, or the year before summer, in 24, and that got me my internship at Meta this year, summer 25. And I did a tiny bit of a pivot, and now I'm working on ML at this startup called Suno. But that's where I am today.
Incredible. Well, we have these 4 amazing alumni from our production engineering fellowship. This fellowship, for those of you who may not be as familiar, has been something that MLH has been running for 5 years now. This last summer was our 5th year running a fellowship program in production engineering in partnership with Meta. And this is just a small fraction of the alumni that we have from that program. We graduated almost 400 people from that program. And I'd really love for our alumni to share a little bit about their experience. So we're going to start with a question. I'm going to start it with Levinson, and then anyone else who wants to can jump in. Levinson, tell me a little bit about, production engineering is often misunderstood. It's sometimes described as like treating operations like a software problem, or like I've heard a lot of different variations on that. Thinking back to your time in the fellowship, what's the biggest misconception or confusion you had about production engineering before you joined the program?
Yeah, thank you, Amanda. So one biggest misconception is that site reliability engineer or production engineering in some companies, they believe that it may be passive work, so they only start working when a system goes down or there's something wrong with the system. So they're not actively building core tools. They're just, you could say, firefighters, right? The reason why this is a major misconception is that not only production engineer actually build new software, they build new software to prevent more manual work, right? So the type of software you could think of that production engineer build is something that would crash. You could think of it like it crashed less times, it involved less manual work, and it's easier for to observe what happened. So if the software crash, production engineer could think about, okay, what is something we could use to best improve the observability if in the case that it crashed. So I believe one misconception is that they do passive work, but it's actually really active work, and they think really deeply about the system on how to make it reliable and improve the observability of the system.
Cool. So it sounds like it's not merely firefighting, though firefighting is part of it. It's also preventative maintenance, if you will, almost like, going to the doctor before there are problems, so that we avoid future problems. Is that about right?
Yes, correct.
Anyone else in the group have a common misconception that they had about production engineering that you'd like to share out? Yeah, Jimmy, go ahead.
I think one of the biggest misconceptions is what it means to be a production engineer and how that definition changes at different companies. So one of the things you'll hear a lot in industry is like site reliability engineer. At Meta in particular, production engineers are more in line with software engineers. That's actually why they're paid exactly the same. And because of that, the requirements are more software engineering based. So depending on the team, you might be required to make more of a product than, let's say, like Levinson was saying, work on firefighting, making some product that prevents something breaking in the future. So yeah, I think one of the biggest misconceptions is like what that word actually means, and that really changes depending on teams individually at Meta and then overall in the industry as a whole.
Yeah, that's really important, and thank you for bringing that up. Like production engineering, or you might have heard of it as site reliability engineering at other companies. It looks very different from company to company, and so building a career in production engineering can actually teach you many different sub-disciplines or specialties in engineering because it looks so different across companies. Awesome. What I'd like to do now is throw a question to Jimena. I think a lot of our audience today is going to be current students, people who are studying for their engineering degrees in university. And I'd love for you to talk a little bit about how is the fellowship different than your traditional college classes? What felt different about the fellowship as compared to a traditional course?
Yeah, sure. I mean, I think the main thing that I could think it's a bit different from a college class is that instead of just going through the topics and learning and just trying to memorize everything without getting any practical issue about it, in the fellowship you are learning new things, but after you learn that new technology or a tool, a framework, you're going to be applying it right away into a currently running project. So I think that's the main difference, instead of just, okay, so here's the topic and this is what it means. Okay, now you're going to have an exam and you have to memorize it. So you're not fully understanding how it works or why you're doing it. So I think that would be the main difference with the fellowship. It's just you applying what you're learning about,
Yeah, it's certainly not textbook learning. It's much more like practical application, which is both good and sometimes I'm imagining frustrating, right? Because like, oh wait, I actually have to know why this thing isn't working. Is that about right?
Yes, exactly. I mean, you can just learn all the theory, but if you're not fully understanding it, you do get a little bit frustrated about it. But I think that's good. That frustration is good because it motivates you to understand even more deeply how it works.
Yeah. I believe that the relevant quote is sort of sucking at something is the first step to being really good at something, and you've gotta fail at it before you can succeed, right?
Yes, I totally agree.
That brings me to my next question. I'll direct this to Eric, and then I'll throw it out to the broader group. Production engineering in particular sort of pushes people who learn it and people who practice it into like a, failure is a learning opportunity and not necessarily a mistake. Like if an app breaks, or if something isn't working properly, we have to figure out how to like avoid that breakage in the future and then fix it so that everything sort of comes back up, right? Like we learn to embrace challenge. Can you tell me a little bit about how your experience in the fellowship changed your approach to breaking quote unquote things, and how you approach that differently now?
Yeah, so it's been a while, so I can't remember that much from the fellowship, but I do remember there's one key moment that kind of just changed the way I thought about troubleshooting kind of problems that happen on my system. And I do remember the problem being something to do with having the file system, like you had something that was just screwing it up. Your computer was slow, and now you have to figure out how to debug it. And when I first started trying to debug it, I was just kind of like, I have no clue what I'm doing. Um, but looking back through all of the notes from the fellowship and just trying to like combine them into like this, I actually ended up writing a little cheat sheet for myself that I'm sure many of my friends probably wouldn't really follow, but it works for me. And that kind of just helped me narrow down these exact issues. And while I don't keep the cheat sheet with me now, but I still use a lot of the things I used to use during the fellowship in my day-to-day work back at Meta, and even now, even as a machine learning engineer, I still every day have to deal with like debugging errors. And I think a lot of the stuff that I learned today or I used today were all learned during the fellowship.
That's awesome. So it sounds like it almost gave you like a roadmap or a cheat sheet as to like whenever anything breaks, and we all know as engineers and technical people, something's going to break. But it gave you the sort of toolkit to address it rather than think of it as failure or disaster or something like that. Is that about right?
Yeah, that's very on point.
Excellent. Cool. Anyone else have either war stories to share or examples of how learning a little bit of production engineering, I see you there, Levinson, might have changed your approach to that kind of thing? Yeah, I'll ask you.
Yeah, so during my internship at Pinterest, when I first on board, they gave me assignment. The assignment was that basically we have this metric collector that collect metrics. Oh, let me provide more. So I was in the traffic team, and specifically in the edge team where we controlled the DNS, the CDNs, and the global load balancing of traffic, right? And at Pinterest, we use a multi-vendor approach. So we have different vendors like DigiCert and like Sodexis for our DNS essentially, right? The background motivation of this software is like the metric collector is that since we're using a multi-vendor approach, it's hard for engineers to kind of dive into different vendor stats board to figure out a problem. So we have this metric collector to kind of centralize and pull those data into one central stats board. Okay, so that's the background of that product. So this product is pretty pre-IPO in a sense that it was really old and it randomly crashed at times. During my internship, I wasn't specifically tasked to fix why it crashed, but it would be a nice to have if I was able to figure it out. Um, at the end, I was able to figure it out. We did some logging and found out that the Go channel had no buffer, so we was dropping data points uh, frequently. So we was able to do the math on how big the buffer should be to kind of uphold the amount of data points coming in the metric collector. And yeah, the metric collector works and it doesn't drop. So that's a major, huge fix. It was definitely a pain for on-color engineers. And I was happy that the fellowship kind of gave me another eye to see, okay, even though I'm not tasked to fix why the metric collector is not working, let's try to debug, and that debugging actually helped me kind of solve the issue.
That's awesome. And what a amazing sort of feather in your cap in your time at your internship to be able to say like, hey, I directly took this practical experience that I got from the fellowship and was able to apply it at work, which is exactly what we hope for when our fellows go out into the wider world. Jimmy, since you were an intern at Meta and are actually returning as a full-time engineer, I imagine you have some stories to share about when things break, as they do. Granted, you were only as if it's easy. It's not easy. Only participated as an intern. I'm curious how much you got to see outage handling, firefighting, that kind of thing, sort of behind the scenes at Meta, to the extent that you can share, of course.
Yeah, so I mean, to add really quickly to the other point you asked about like what are some troubleshooting techniques that we learned, I think one of the most important things we focused on in the fellowship was Linux, because I don't know, there's some stat like 97% I think of servers run on Linux. So just that fundamental idea of what operating system is used and how to mitigate issues that come along with that operating system. So in the fellowship, you'll learn how to investigate memory leaks, what a memory leak is, how to look at different resources through a computer, maybe what's being taxed more, so memory versus CPU. In that same note, during the internship, there was several moments, maybe even weekly issues that would come up, because essentially what happens is there are on-call rotations. So an on-call is someone that comes in and is scheduled to fix any issue that may come up on a team at any given point. So those rotations change. I think they're weekly, maybe sometimes bi-weekly. It depends on the team size. But essentially, an issue will come up. Some person is tasked to fix it. And all the time was there issues of, let's say, a memory leak. Now, how do we deal with a memory leak? Maybe we maybe do a memory dump. And these are things that will be touched on during the fellowship. I mean, there's a lot of detail to get into. But essentially, depending on what the issue is, it all fundamentally comes down to what's the operating system and how do I use different aspects of that operating system and the data it provides to me to access and look into issues. So like I said before, looking if any application is leaking memory, what may cause that? Back to Livingston, maybe we have some metric that we're writing. Aside from memory leak, maybe something is using too much CPU. Maybe it's spawning new processes. How do we see that in Linux, right? So these are all things that'll be touched on during the fellowship, and that are fundamentally related to the operating system and how to fully exploit what the data it provides.
That's awesome. So something that's so fundamental that you learn in the fellowship, because I think we handle Linux fairly early in the program, if I remember correctly. Then you're working with it all the way throughout, and then it must have felt very like empowering to see that happen in the workplace, and then be like, hang on a second, I've seen this, right? Like I've worked with this before. Am I right?
Not only that, I think one of the also key topics picked up on that we spent around 2 or 3 weeks on in the fellowship was observability. So now if some process isn't working in the way it's expected, how do we even see that, right? We don't want to get to the point where we're actually looking at PID processes themselves and seeing how much data they're taking up. What if we create a dashboard to see any particular service that's taking up more resources than another, taking up more resources than it historically does? So these are all like really important points that are related to both the operating system and observability, reliability, production engineering as a whole.
Fantastic. Thank you so much for sharing that. Wonderful. So I want to sort of turn the conversation, since this is Global Hack Week for AI and machine learning. It overlaps with production engineering a little. And I'd love to hear really from anyone who has feedback to share on this. How is the overtake, if you will, of AI tools and machine learning models and things like that? How, if at all, have you seen it impacting the work of production engineers? in the wild, if you will, in the work that you all have done professionally. Maybe Eric, I can start with you because I know you are you're working in machine learning right now, correct?
Yeah, so I currently work at a startup. They're called Suno, and they actually do music generation. So lots of generative stuff happening here. And actually, I think everybody here on the team pretty much uses AI for code generation. I will say I did want to start off a little bit with the production engineering side. And I think commonly ways I've seen it used at Meta and among coworkers was actually for two things. One was just helping write tests, so doing test-driven development. And then and the reason that works really well is because you already have the solution in mind. You have these things, metrics that you want to hit, like stress tests, for example. And if you can quickly just generate code for that without having to think about how am I going to set this up, then sometimes that just really makes it easy for you. With bigger tests like integration tests, it so far doesn't work quite as well yet, but it's getting there. And the second way I've seen it used is not so much so as meta, it's just more for sort of planning. So having this plan that you, let's say I have this solution or idea in my mind, I can try to plan with a model like Cursor, and basically I can set up this let's say markdown file that has a plan of everything I want and implementation details. And the reason people actually, I've seen almost everyone I know do this, is because it keeps the models that are running grounded to some kind of ground truth, and that is your markdown file. And that actually really helps with implementation. And if the model so ends up deciding to forget something, you can point it to the code, but you can also point it to the markdown file. So though that's how I've seen AI used around.
Oh, fascinating. And it sounds like that kind of like use of a markdown file to sort of keep things on the rails, if you will, probably saves engineers a lot of time to work on other things, build new tooling like Levinson was describing, or do the firefighting that actually has to happen, because the AI model can handle sort of holding the context for everyone. Is that about right?
Yeah, that's about right. And it also just helps it self-develop.
Yeah. Awesome. Who else had, I feel like someone else wanted to add something on this question. Anyone else have thoughts on this? Levinson, I thought I saw your hand. Yeah, please.
Yeah, so at Pinterest, there is a new team called Helix that received funding, and the goal of Helix, our AI, is to kind of read all of our documentation and text message, Slack messages, to kind of help engineer accelerating coding. Um, they just made they're just branching out to observability. So, for example, if we have a crash at Pinterest, we could go to this Helix box and say, hey, what are the recent change event that happened during this time? And it will pull in like the PR codes around, I guess, related to that type of crash. And I believe that was very impressive for the Helix team to kind of do. And it's definitely a help up for production engineering to easily debug any crashes with the help of AI.
Amazing, sort of automated smart documentation, it sounds like is a hugely valuable application of AI in all of engineering, not just production engineering. Because let's face it, which engineers want to be working in documentation, right? You never want to be working in documentation. So let the AI do that. Fantastic. So I'd love to add on this a little bit for folks who are in a university right now who are just thinking about starting their career journeys. How do we think, and Jimena, I might ask you to start here if you have thoughts. How do you think the skills of an entry-level production engineer, or really engineer at all, will need to change as young students are now entering the workforce? What should people focus on learning, do you think?
That's actually a good question. I mean, I think AI, it's gonna have a great impact in the skills of a production engineer further on, but it's gonna be dependent on how you're gonna use it, because you can either be completely dependent on AI writing all of your codes and doing all of your documentation, and you're not understanding nothing but delivering to your employer or whoever you're presenting a project to. Or you could use it as a really great tool to understand more deeply how a code is working. So maybe you can use AI to generate a code, and the AI decided to use a library that you don't know. So instead of just being like, oh, cool, okay, so that's done, perfect, moving on, you can be more curious about it and think, okay, the AI is using this library, but why? And how is this helping me? How is this solving the problem more efficiently than me using a function or something like that? So I think it's going to be a 50-50 between very good for production engineer or very bad. It's going to be dependent on the motivation that the engineers have.
Right. We don't want to end up in a place where we're completely dependent on the AI and then we sort of get ourselves stuck and unable to fix something without it. But at the same time, having the skill to communicate with the AI almost like it's a colleague and say, hey, how did you solve this? What made you go into this documentation? Why did you solve it that way? Right? Like there's a curiosity one can bring to it that can potentially expand your ideas. Is that right? Is that about right?
Yes, that sounds about right.
Fantastic. Jimmy, anything to add on this from your meta experience, specifically the idea of like how AI skills will become necessary in the coming years?
Yeah, I think in general, learning AI and how to communicate with it especially is becoming super important. So I think now the limitation to implementation is probably how well you're able to describe what you're looking for. And like Amanda was saying, I don't think it makes sense to just produce without looking at what you're producing, because eventually that will become almost spaghetti code that's impossible for any one human to look at. I think it makes sense to, one, learn how to communicate effectively, see the results of your communication in terms of like what's being outputted by said AI, and three, actually reading through it. So asking why decisions were made, maybe if those decisions were right, because even me using AI, that's not always what I'm looking for, and how to just iteratively use AI towards a given solution that you're looking for.
Absolutely. Then coming back to that same theme of like communicating with it as if it is a colleague or a partner or a useful, someone with a different understanding of engineering than you, but also a valuable understanding so that you can sort of get different perspectives in there. That's awesome. I love that thread that we keep coming back to in this answer, which is it's not a replacement. It's an addition. It's a colleague. It's a new kind of tool / communicator that we'll all need to be talented at communicating with, frankly. So thank you all for sharing your thoughts on AI and how that's impacting the world of production engineering. I'd love now to finish up with some questions that are sort of specifically about your fellowship experience, because we get thousands of applications for this fellowship, and while we have hundreds of alumni, you all are the ones who have seen it from the inside and can maybe give some advice or reflect on your experience in a way that will help other people participate in this program in the future. So I'll throw this out to all of you, but I'll start with Jimena. I'm sure everyone watching this is worried about the engineering job market and, are there going to be any jobs for me? How can I possibly differentiate myself when I'm ready for this? So can you reflect a bit on how, if at all, the fellowship helped you with your interview process and understanding how to work within the job market?
Yeah, sure. I would love to. I mean, I think the main thing that I got from this fellowship and what I'm really thankful for is it gave me a bit more confidence to speak up. So in my interview process, I tended to be more shy and to not to worry about the questions that I was asking the interviewee and just trying to always say the right things. And after the fellowship and doing the mock interviews and just figuring, maybe I'll just try something new. Maybe it works, maybe it doesn't, but that's not gonna kill me in the end. So it's only going to make me stronger. So that's actually the strategy that I use for this job. I try to, instead of just giving the right answer about the question that they were giving me, I was giving my honest answer and just be as genuine as possible. And thankfully, that's how I got here. So I think that would be the main thing that I got from the fellowship that helped me get this job right now. Because I would like to talk a bit more about the engineering part, but since my job is more on the surface level of software, it's not that involved right now.
No, that's great. And I think, you alluded to something that is a really important part of the production engineering fellowship, which is the mock interviews, which I think everyone dreads and everyone's afraid of, but consistently everyone says they're the most helpful thing. Does anyone else want to share just a little bit about what the mock interview process is like in the fellowship? Yeah, Jimmy, go ahead.
Yeah, so that I think that was one of the most useful experiences. Even having done interviews before that, the way it was structured, especially the curriculum to follow, is super helpful and informative. So you are given exactly what to study for, exactly what to expect, and then after, how to improve. And I will say, make sure to go through the curriculum. Like, make sure to actually study the material, and review the feedback, and maybe even ask questions about the feedback beyond what was provided.
Wild idea, actually read the curriculum and read the feedback, right? But no, and it is genuinely, interviewing is a skill like anything else, and you have to practice it to get good at it. And I think, well, actually, I'll put it to you, panelists. Raise your hand if you thought you messed up your first mock interview. Mock interview 1 didn't go so well. Yeah, basically everybody, right? Because your first of course your first interview isn't going to go well. You're just learning the rules. You're just learning how to handle these kinds of questions, whatnot. And I think that creates a lot of fear in people. But all 4 of you stand here testament to the fact that it is something that you can learn. It's something you can get better at, and you will survive that first interview not going well if it powers you, and especially since it will power you to having an interview that goes really well in the future. Jimmy, you have something to add?
Yeah, and like, take it seriously. It is a mock interview, but treat it like a real interview. And I think that's how you'll be able to learn the most and get the most relevant feedback.
Oh, absolutely. I hear from fellows every year we run this program, and we get 1 or 2 fellows for whom the feedback is like, they didn't really seem to be taking it seriously. And it's just like, it's, this is a rare opportunity. Like, put your whole self into it, right? It's not easy, but it's worth it. Awesome. Thank you all for your thoughts there. Similarly to interviewing being a skill into and of itself, things like communication and working in teams, negotiating with your fellow engineers about relative priorities and whatnot, that is also a huge part of working as a production engineer. Jimmy, can you talk a little bit about how you saw what we'll call, quote unquote, the soft skills of engineering show up during your internship at Meta, and how, what impression that made on you?
Yeah, so I think in general, in any career, and one of the first things my manager told me was the only thing differentiating you from a, let's say, salesman is writing code. Meaning the ability to communicate is as important as it is for a salesman as someone that writes programs, software. The only thing that should necessarily allow someone to pick my solution over another is how well I could explain myself, how well I could advocate for myself. So I think in general, learning how to communicate effectively, as I said before, that's the only thing limiting you. And now with AI too, between you and a solution, between you and success. I think people often overlook, like, oh, it's software. I don't really have to be communicating. No, you're working in teams with 8 to 10 people. You have to communicate to your manager. Why did you choose a certain solution? What's the solution you're going for? And especially, like, learn. How do you learn, right? To start learning, you have to learn what to ask, how to ask, and just how to be enjoyable in the office. Like, Meta especially is a social company, so you have to be social.
That's such an important observation there, Jimmy, that you ended with, right? Like, I think there's an outdated belief that engineers just like sit in quiet rooms with like darkened rooms with like monitors glaring in their faces, and that's all engineers do every day. And it's just not true. Like, it is a social and collaborative type of work, just like anything else. Um, Others on the panel, you all have worked professionally as interns or as full-time engineers. How have you seen your soft skills develop throughout your time as a professional engineer? Eric, I see your hand, and then Levinson, I'll go to you.
Yeah, so I'll say I learned a lot from observing my coworkers actually. And there's quite a fun number of things back at Meta. I was on this team that worked with recommendation systems and more so actually serving them and putting into prod. And in doing so, that meant they had to interface with every single team that had a recommendation model out there. And that's quite a lot, I'll say. And it was funny because every time there was an incident and that happened like at least 10 to 20 times a week, we'd actually have to locate who did it. And it's kind of funny because in order to find out who did it, that actually involves like just communicating to people, figuring out what they're working on, what kind of changes happened recently, knowing who knows these people or who knows this team. And that all just becomes a matter of like communication. The less you can cut these jumps from person to person to find out somebody who knows more details about this problem or somebody whose model they know something happened with it, the less communication jumps you have for that, the better. And as a separate story, it was kind of funny because there is a fairly big architectural change that occurred within my team. Not fairly big, it was an optional things that teams could opt into. Um, and with that architectural change came no testing environment at all. So it actually turned out that they were just being straight up tested in prod. So if some recommendation models ended up not working or feeling a little wonky, it could be because of that actually. And I know there's a whole effort of like convincing upper management or like just talking to people and being like, hey, this is an effort that we need to focus on. And that ended up being a project that ended up being started.
That's awesome. Thank you so much for sharing all of that context, Eric. Levinson, I know you had something to add as well.
Yeah, so I believe that along with like communication and observing your team, I also believe the art of collaboration is one major thing. During my time at the internship, my first few days, I actually did not know the code base at all. This is my first time seeing Golang code. And during the first few weeks, I wasn't coding alone. It was me and my mentor. Well, he wasn't actively writing the code, but he was telling me, here, look at these files. This These are the type of files that are responsible for this. This is how we're actually pulling data. At this time, the metric collector had no documentation. I fixed that now, but since it had no documentation, uh, I feel like it was a good thing because I was able to kind of collab. Hey, since the service had no documentation, can you please kind of collab with me on how we could figure this thing out? Also, during my time at Pinterest, there was a few sub-zero incidents actually, so very bad incidents, and there was time where I was invited to the ward room, and you see nothing but collaboration. So they're looking at the change events. They're looking at, okay, for example, let's say a service is being overloaded by another internal service. Why is that happening? Okay, one of the team responding, hey, we just made this new change that may be the reason why we're increasing requests from this service. Okay, they figure it out. Maybe the solution is to scale the service to handle the request, and that collaboration actually would fix issues faster. So I believe that collaboration is another very important skill, alongside with observing and communicating.
Absolutely, 100%. It's a question I get fairly often from fellowship applicants, which is like, why do I have to write essays? Why do I have to do a behavioral interview? Shouldn't it just be about the code I can write? And y'all are standing here as excellent examples, all of you, of why we have you write essays, why we have you do behavioral interviews. It's such an important part of being a successful engineer and being able, as you point out, both Eric and Levinson, to make an impact in the industry. So much of it comes down to your communication and not just, what you can do in your command line interface, right? Awesome. So I'm going to move on to the last question that I have for the group. In the meantime, though, I want to encourage everyone watching to drop your questions in the comments, please. I have a couple that have come up that I've saved to the side that I'm going to share when we move on to audience questions. But now would be a really great time to drop the questions that you have in the chat so that I can pull them in and present them to the panelists when we're ready to go. So while y'all are doing that, I will close with my question, and this is really directed to all of the panelists. So anyone who wants to answer this, please feel free to just raise your hand, which is, if you think back to your prior self, yourself sort of before the fellowship, before all of these experiences that you've had, if you could give that self one piece of advice, not necessarily about code, maybe about career prep, maybe about taking care of yourself, anything at all, what would you say to the version of you a couple years ago that hadn't yet had all of these experiences? What's the advice that you would share? Jimena, you can go first.
I think this is actually a very important question, because maybe all of the panelists here can agree with me that a big deal that software engineers deal with is imposter syndrome, because we tend to feel like we're not supposed to be here for some reason. And my advice would be that that's actually something that I dealt with when I was in the fellowship, because I was feeling like, I don't even speak proper English. I don't know what I'm doing here. This is so weird. I'm taking someone else's place. And my advice is, if you are there, it is for a reason. You do have the skills and you have to believe in yourself. And that's very important, because if you believe in yourself, everyone else around you will. So I think that would be my main advice. And I know it's weird if you're dealing with something to be like, just don't do it, just take your own advice. And some people don't, like I don't, but it's something that you should be working on all the time.
Absolutely. And to your point, Jimena, there's a reason you and the rest of the panelists and the people who we selected were selected for the fellowship, right? Like every single person who, whether it's the fellowship or an internship or a university program or what have you, like, you are there for a reason. Many, many people looked at your application or talked to you or interviewed you or what have you and said, yes, this person. Take that and let it power you. Don't necessarily have it make you shrink, because we want you there. We are here for a reason. That's excellent advice. Who else has a piece of advice for their former selves? Levinson, I think you did. Yep. Mm-hmm.
Yeah, so one major piece of advice would be to join an organization whose mission is to help you succeed. This is, I'll say, within software engineering and production engineering, it is a long fight. 4 years of school and additional learning outside of class. So you'll sit in the learning phase in a while, and if you don't have to fight alone at all. So like with orgs, you could maybe have someone to take each other accountable. Hey, we're doing this study session. Would you like to go? And you would like to go for like the social factor, even though you wasn't planning yourself to study for that day. The fact that the org is studying mean that you're kind of more inclined to go. So you kind of have that indirect responsibility to kind of participate in the org that will help you succeed. So I believe that joining an org, whether it's MLH, whether it's an org from your school that do CS, I believe that doing so will make you again not fight alone, but also like work as a team, and even talk to someone that is that you want to be at that spot one day within the org, like, hey, I see that you got an internship at this company. What was some of the things that would help me, right? So definitely join an org. That's my biggest advice.
I love that. Find your community, find the people who are gonna like hold you up and lift you and help you be like the best version of yourself. I think that's such incredible advice. What else? Jimmy, Eric, anything to add?
Yeah, I can go.
Yeah, go ahead.
So regarding career, I have, for the people who like to put themselves in high pressure situations in order to improve their career, I actually quite think it is really good to find the most uncomfortable place you can be in. And I feel like imposter syndrome is actually a really good indicator of that. Because if you feel imposter syndrome, then you're in a place where you're uncomfortable and have a lot of room to grow because you have a lot of coworkers you look up to, or because there's a lot of knowledge and just things to be learned. So I feel like chasing after these uncomfortable situations is always a great thing to do. On the other hand, if you're in a high pressure situation and you're struggling with your mental health, which often happens, I do think like sometimes it's not the end of the world if you're not able to capitalize on the opportunity. And I think a lot of really important value is just in being able to take rest and knowing that in resting, you'll be able to wake up on another day with a clear mind and have a better mindset just to work on problems. Oh, sorry, I think Amanda,
Silly,
you're muted.
silly me. Yeah, silly me. You'd think I'd learn how to unmute myself at this point in my life, but I think Eric, it's such an important point. Like, there are times where you want to push yourself really hard, and there's times you want to challenge yourself. And I think your advice sort of encompasses that. Like, don't be afraid of like taking on a challenge, but also take care of yourself, right? And listen to yourself. And no one can go at 90 to 100% of their capacity all the time. Sometimes you need to just kick back and play a video game and like let your brain rest. And I think like giving yourself permission to do that, it's hard, especially when you're early in your career. But it's also important for your effectiveness. And Jimmy, I'll turn it over to you, and then I want to move on to questions from the audience. So go ahead.
Yeah, I think just to second what Jimena and Eric said, it's really important to understand that you are where you are for a reason and to capitalize on that opportunity. I think there were several points throughout the fellowship, the internship. I didn't feel like, I feel like, why was this opportunity given to me? There are hundreds, several more people that are smarter than me that I know of. And I think, again, you're there for a reason. Like there's something particularly interesting about you, which is why you were selected over someone else. And yes, there's a luck component to that. But as long as you capitalize properly and take advantage of it and prove to yourself and whoever hired you, right, that you're worth it, will mean the world to you and them. So I think, yeah, capitalize on the opportunities, and you are where you are for a reason.
Yeah, and I would add to that, Jimmy. I think you're absolutely right. Like luck does come into it a bit, but I also think you can improve your own odds by giving yourself a lot of the way Swift puts it is give yourself a lot of swings of the bat, right? Like don't apply to one program, don't ask to join one coding club or something like that, but like spread it out. Give yourself lots of opportunities because you only need one lucky moment in one of those things for it to be the thing that builds to your success, right? So
Right, like be prepared.
Exactly.
Yeah.
Exactly. Excellent. So now I'm going to go ahead and share some questions that have come in from our audience. I'm going to start with this one from Titan2K. I think I know what y'all's answers will be to this, which is, did any of you have production engineering experience prior to the fellowship? Who wants to take that one? Levinson.
Yeah, so my answer is no. I actually didn't know what really was a production engineer. My prior experience before the fellowship was actually being a tech fellow, so a teacher at CodePath. So I won't say I have very little technical experience. I had side projects, but when it comes to production engineering, very little prior experience, I'll say.
That's what I figured. Jimmy, yeah, go ahead.
Yeah, I think even when first getting admitted to the program, like I knew what MLH was. I mean, they run hackathons. I got admitted, and I didn't even know what production engineering meant. Like I remember immediately after getting admitted, I looked it up. So to say, did I have an experience? Absolutely not. And again, I think this kind of harkens back to what we were saying at the beginning. The definition changes. Did I have experience bug fixing? I guess, but not to the point of how to actually implement that into what might be like I guess what I may face in a career like opportunity.
Absolutely. And I want to emphasize for everybody watching, like the production engineering fellowship is designed to take you from zero. Like essentially no one comes into the program with production engineering experience, and that's because it's not a skill that's typically taught at universities. It's not like you can go take like a Coursera course or something and be like, how to production engineering. Like it simply doesn't really exist. It's the kind of skill that people learn by doing. They learn it in inside of their careers. Many people who become production engineers actually started as software engineers and just sort of like slid into that specialty over time, which I think it makes it a really interesting engineering subdiscipline, because everybody who's there is there because they found something in it that they really were excited about. Nobody wakes up when they're 12 years old and is like, production engineering, that's what I want to do. But you find your way to it, and everybody who's there is there because it lit something up in them. Eric, what would you like to add?
Yeah, I just wanted to mention, I also think so. I'm sure there's people who are not interested in production engineering itself as a role. And I do think, like, for me, I came into the fellowship as a software engineer and I left the fellowship as still more so a software engineer, but with a new set of skills that I've actually just used everywhere I've gone. And I think that in itself has been incredibly valuable. So while you don't have to be a production engineer, I think the fellowship will teach you essential skills that anyone could use.
Absolutely, yeah. The fundamental skills that you'll learn in the production engineering fellowship will serve you well, regardless of what you go on to do inside of engineering. Excellent. So I'm going to move on to our next audience question. This one is from Tammy. Tammy would love to know, what did you find most difficult during your fellowship? What was the biggest challenge? I'd love to hear from anyone. Yeah, Jimena, go ahead.
Yeah, I think the most difficult thing that I had to deal with was to break the stigma of you have to know everything and you cannot ask any questions, because that's what the fellowship is for, to learn as much as you can. And the fellows around you are also very smart, very capable people. And I think everyone in the community is very open to helping each other out. So I think that was the most difficult part for me, just being brave enough to say, I don't know this, and I would like you to teach me that.
I think there's a fabulous answer, and thank you for sharing that, because I know for sure there are people watching this who don't raise their hands or don't ask questions or don't want to look silly, admitting they don't know something. But guess what? Like that is, in fact, the most powerful way to learn. So thank you for sharing that. Who else has an answer? What was the most difficult thing during the fellowship? Levinson. Mm-hmm.
Yeah, the most difficult thing in the fellowship for me was my first mock interview. So we was given a question, basically, if your system's slow, what will you do to solve it? And I mentioned maybe we should look into the code. Of course, the interviewer say, what if you can't look into the code? I mentioned like networking, maybe we could look into the network. He mentions that how we could look into the network. I kind of pivot to maybe we could look into CPU. He mentioned how we could look into CPU, not knowing that I did not know like there was actual commands and troubleshooting. That was bad preparation on my part, but I feel like that was the hardest part of the interview. Of course, I did kind of rebound from that, and I was able to dig myself a very deep rabbit hole when it comes to troubleshooting and Linux command for like the CPU, memory, disk, and networking. So I feel like that was the most difficult part of the fellowship, but that was something I really needed to kind of dive into, like Linux troubleshooting commands.
No, absolutely. And sometimes it is those kinds of experiences that surface for us exactly what we need to be focusing on, or how we can make ourselves like a key leverage point for how we can make ourselves a stronger engineer or a stronger worker in the future. Anyone else have a story to share? The most difficult thing during the fellowship? Jimmy, go ahead.
I don't know. The wording is bothering me because I think any difficult part of the fellowship was made really easy. I mean, we had meetings throughout the week. Any blockers is what we call them, and that's generally what we call them in the industry. So anything that you'd come across that would prevent you from making progress was immediately, you had every opportunity to fix that. So any difficult thing that I came across, and I think like Levinson, it was probably the first interview, it was easy to work through.
That is awesome. Yeah, and that's really the key thing about the fellowship, is that it is a space for learning. So we expect you to not know everything. We talked about it just a couple minutes ago, right? Like, no one came into this program with any experience. The expectation is that you don't know what you're doing. And the fellowship is a safe place to ask questions and get the kind of support that you're describing. So it's really, really wonderful to hear you describe it that way. The last question is actually for me, because somebody wants to join the fellowship and is asking whether we'll be offering production engineering in the spring. So Fizz says, hey, Amanda, do you know if Meta will be participating in the spring? I'm really hoping to get into the production engineering track. So the answer is no, but also yes. And the reason I say that is that we run the production engineering track one time a year, and it is always in the summer semester. That is because that is the timeline that best lines up with the Meta team's availability. And also it is the time of year when they themselves learn how many people they're going to be able to hire in the new year. How many interns are they going to be able to invite in the new year? So it's the best positioned time for someone to graduate from the fellowship and then immediately become eligible for something like an internship. So the PE program itself will be running not in the spring, but in the summer. That said, stay tuned because this spring we are very deliberately, and I'm very excited about this, doing more events and experiences related to production engineering because we've been doing this program with Meta for 5 years now, and they've seen the success and our fellows have seen the success. We want to take aspects of it out to more of the MLH community. So keep an eye out in future Global Hack Weeks, where we'll be doing more panels, discussions, learning experiences on how to be a production engineer, the core skills of being a production engineer, and we may even have more exciting events to announce in the future. We've been hacking away at the idea of a production engineering hackathon for a while now. It's not quite ready for prime time, but I think we're getting there. So keep an eye out for that. If you are hoping to learn more about production engineering or give yourself a leg up into getting into the production engineering track, keep an eye out this spring for more events from MLH that will be focused on production engineering, because we want you to get into the production engineering track too, and we want to provide the resources that you need in order to do that. All right, so with that, we are essentially at time. Thank you so much to my panelists, Eric, Jimena, Levinson, and Jimmy, for coming and talking about their experience. They stand here as evidence that, one, you can get into the fellowship. Two, you can graduate, and it's an incredible thing to have on your resume, an incredible experience to help you be the strongest possible engineer you can be. So thank you, everybody. I'm waving my audience. Bye, audience. Thank you all so much for coming, and we'll see you in the jam. Yeah, absolutely. Hard hands. I'll do it because I'm old. I'll do it the Taylor Swift way. I'll do hard hands. There we go. See, Jimena can do it. And we'll see you hopefully in January's Global Hack Week for our next production engineering focused event. Cheers, everybody.
Bye, guys.